Okay, you may want to know what ocean acidification is, and these slides show that the increasing atmosphere, in the atmosphere, the CO2 levels are increasing. We know that. The oceans actually have absorbed about 30% of that CO2 since pre-industrial times. So they've been buffering climate change, but at a cost, because when you add CO2 to seawater, it becomes more acidic because it forms carbonic acid. And it also then ramifies through the rest of the carbonate cycle, affecting the carbonate ions that marine organisms use to make their shells, and also reducing the pH of the water. And all of us have to regulate the pH within our bodies, and marine organisms have to do that as well. By 2060, using the IPC scenarios, ocean acidification, or pH, could decrease by 120% unless we reduce our CO2 emissions. So it's already been reduced by 30%. And it's going very, very quickly. Next slide, please. Now, so what? Well, you know, haven't marine organisms experienced these changes before? Well, not in the last 20 million years or so. This is going back through time that way. 20 million years ago, you can see that the changes in pH. And this is what we're going through at the moment, this rapid change. And these are the projections for the future. So by 2050, we'll be beyond what marine organisms have experienced for that time. So that's why we're concerned. Next slide. So why the Arctic? Well, ocean acidification is a global issue, so it's not just the Arctic. And you can see here, this is atmospheric CO2 concentration, so we're just around here, 380 or so. And this is what will happen in the future in terms of the calcium carbonate ion. These are what organisms use to make their shells. And you can see tropical oceans. There's a growing decrease with time, which is very serious for things like corals that use these carbonates to make their skeletons. But you can see, because the Arctic oceans are colder, they absorb more CO2, that the natural levels are much lower anyway. And as you progress through time, see around 2050, which is a couple of decades, it could become undersaturated in this really important mineral. That is, the concentrations won't be sufficient to maintain shell production. In fact, if you have an unprotected shell, it could dissolve. And you can see that the Arctic Ocean is the most vulnerable to this, that it's likely to happen early on. Next slide, please. So we think that the Arctic Ocean will be the most vulnerable earliest, and we need data desperately to help test those models. You know, and it's not easy to get data from there, as you can see, and so it's really essential for scientists and experienced polar explorers to work together to help sample this really vulnerable but extreme environment. And that's why Plymouth Marine Laboratory, for example, is sending one of its polar experts to join the expedition of Catlin. Thank you.